My photo taste is the Pinterest, because they are the best.
I thought you might ask me that, and I thought I would become furious if you did, but I haven't.
No, you're very
I'll
confident.
save my fury
Save your
after
fury.
the recording. Right then, before we recap the words that we've looked at today, we have, of course, our Facebook challenge. Now, we've been talking about blackmail, which, as we've said, can be a criminal act. And here is a test of your knowledge of financial crimes. Okay, so we asked, which of these is not a financial crime? Is it A, fraud, B, bribery, or C, windfall?
Oh.
So, how was the response?
The response was great, as usual. So the correct answer, well, let's go to Matori Nakatsuka, who said, I'll go for C, windfall. I think fraud means cheating and bribery seems to have something to do with corruption. So, yep, the answer is C. A windfall means unexpected money that you get either because you win it in a competition, or you get a bonus at work, or you find something under loads of money you forgot about under the bed.
Yeah.
Or so it's money that you acquire legally, but it's unexpected. So nice surprise. Whereas fraud and bribery are financial crimes. So well done, Alex Liu. Well done, Arezzo Gulistani. Well done to Sarah Idris and everybody else who said windfall.
Great, and now it's time for a recap of the words we've looked at, please.
Yes, we have leak, which means to make private information known to the public. Blackmail, meaning to get money from or make demands on someone by threatening to reveal their secrets. And finally, fury, which means great anger.
And if you would like to test yourself on today's vocabulary, there is a quiz you can take on our website, bbclearningenglish.com, where you will also find all kinds of videos and activities to help you improve your English. Thanks for joining us, and goodbye.
Goodbye.
Hello and welcome to News Review, the programme where we show you how to use the language from the latest news stories in your everyday English. Hi, I'm Neil. Joining me is Catherine. Hello, Catherine.
Hello, Neil.
So, what have you got for us today?
Got a story today about someone who's just lost their job.
Someone who's lost their job. That doesn't sound very nice, does it? Let's find out more from this BBC World Service News Bulletin.
President Trump has fired his acting Attorney General, Sally Yates, hours after she told Justice Department lawyers not to defend his controversial travel restrictions against 7 mainly Muslim countries in court. A White House statement accused her of betrayal.
So, as you probably know, a few days ago, President Trump gave an order banning people from 7 Muslim-majority countries from entering the United States of America. Now, there's been a lot of disagreement about this policy, and the U.S. Attorney General, that's the head of the Justice Department, has told Justice Department lawyers not to defend the ban in court. And as a result of this, President Trump has removed her from her job.
Okay, well, you've been scanning the news websites for this story, and what are the words and expressions which are useful?
Okay, so today we're going to look at sack, fire, defying, and betrayal.
Sack or fire, defying, and betrayal. So let's start with that first one, sack or fire.
Okay, so on the BBC News website we have the headline, Trump sacks defiant Acting Attorney General Sally Yates, and on Sky News, Trump fires Attorney General over travel ban.
So both sack and fire, meaning remove from a job. What is the difference between those?
Well, they're pretty much interchangeable, but fires is generally American English, whereas sacked you'll hear more in British English, although British people do understand fire and sack as having the same meaning.
Yeah, they're both quite sort of short, dramatic words, aren't
Very short, very dramatic, very informal. You don't see them very much written down. You wouldn't put it in a formal letter. You wouldn't probably put it in a formal email. The formal word is probably dismiss.
Yes, and these words are often used in the passive, aren't they?
They're used, you can be fired, you can get sacked.
Yeah.
Yeah, we often use them in that way, yes.
Yeah, and then there's an expression in British English. We say to give someone the sack.
You can give someone the sack. You're not literally giving them anything, but it means you're removing them from their job, usually because they've done something bad or because they haven't performed or succeeded in their job very well.
Yeah, this is not a nice way of losing a job.
It's not
redundancy or retirement.
No, it's not a happy ending. You're not leaving because you want to. You're leaving because you've been told to leave because of a problem that you are responsible for, usually.
Yeah.
Yeah. Ever been sacked, Neil?
What an incredible question. Have I been sacked? No, I've never been sacked, but, there's time yet.
There's time yet. We'll see if we can sort something out.
A possible reason for being sacked or fired could be connected to this next word.
Next word, okay. So we're moving on this time to the Independent website. The headline says, Donald Trump fires acting Attorney General for defying executive order banning refugees. So, defying.
Yeah, defying meaning refusing to obey.
Yeah, and it can be, you can refuse to obey a person in authority, you can refuse to obey an order, you can refuse to obey a rule. And if you do this refusal to obey, usually as an act of protest because you don't like what you're being told to do, that we call it's defiance, or in this case, in a verb form, defy or defying.
Yeah. Yes, it's a deliberate act, isn't it, often?
You're showing your displeasure or your disagreement, and it's quite an aggressive act. It's a protest. You don't do it quietly. Usually an act of defiance, and that's a really nice expression, act of defiance, is something you do to show that you really don't like what you're being told to do.
For example, if you were a smoker and you thought that it was your human right to smoke anywhere, and you went into a restaurant in this country and many other countries where smoking is now illegal, is banned, and you took out your cigarette and lit it.
Proudly. Angrily.
Exhaling your smoke.
In the manager's face.
Yes.
That would be a large act, a strong act of defiance. You probably would be removed from the restaurant. And if you did it at work, you might get sacked.
Yes, absolutely. Which leads us on now to our third word and headline.
Okay, so now we're looking at ITV News website, and the headline here is Trump fires Attorney General over travel ban betrayal.
Betrayal, an act of not being loyal.
Yes.
So it's a little bit like defiance, isn't it?
It is, in a way. It's where you're doing something opposite to what is expected of you, or opposite of what people think you're going to do. With defiance, you're protesting, you're doing it against rules and authority. With betrayal, you're doing something which works in opposition to friendship or trust. Yeah.
So, for example, perhaps you support a certain football team.
Yeah.
And you've got a star player, a guy that you really love.
Yeah.
And then, one season, he decides to play for the city rivals, the closest rivals,
next door
the team that you hate. So, maybe you support Manchester United.
My photo taste is the Pinterest because they are the best. Flick to link, a link to flick.
There is something about physics that has been really bothering me since I was a little kid. And it's related to a question that scientists have been asking for almost 100 years with no answer. How do the smallest things in nature, the particles of the quantum world, match up with the largest things in nature, planets and stars and galaxies held together by gravity? As a kid, I would puzzle over questions just like this. I would fiddle around with microscopes and electromagnets, and I would read about the forces of the small and about quantum mechanics, and I would marvel at how well that description matched up to our observation. And then I would look at the stars, and I would read about how well we understand gravity, and I would think, surely there must be some elegant way that these two systems match up. But there's not. And the books would say, yeah, we understand a lot about these two realms separately, but when we try to link them mathematically, everything breaks. And for 100 years, none of our ideas as to how to solve this basically physics disaster has ever been supported by evidence. And to little old me, little curious, skeptical James, this was a supremely unsatisfying answer. So I'm still a skeptical little kid. Well, so flash forward now to December of 2015, when I found myself smack in the middle of the physics world being flipped on its head. It all started when we at CERN saw something intriguing in our data, a hint of a new particle, an inkling of a possibly extraordinary answer to this question. So I'm still a skeptical little kid, I think, but I'm also now a particle hunter. I am a physicist at CERN's Large Hadron Collider, the largest science experiment ever mounted. It's a 27-kilometer tunnel on the border of France and Switzerland, buried 100 meters underground. And in this tunnel, we use superconducting magnets colder than outer space to accelerate protons to almost the speed of light and slam them into each other millions of times per second, collecting the debris of these collisions to search for new, undiscovered fundamental particles. Its design and construction took decades of work by thousands of physicists from around the globe, and in the summer of 2015, we had been working tirelessly to switch on the LHC at the highest energy that humans have ever used in a collider experiment. Now, higher energy is important because for particles there is an equivalence between energy and particle mass, and mass is just a number put there by nature. To discover new particles, we need to reach these bigger numbers. And to do that, we have to build a bigger, higher energy collider. And the biggest, highest energy collider in the world is the Large Hadron Collider. And then, we collide protons quadrillions of times, and we collect this data very slowly over months and months. And then new particles might show up in our data as bumps, slight deviations from what you expect, little clusters of data points that make a smooth line not so smooth. For example, this bump, after months of data taking in 2012, led to the discovery of the Higgs particle, the Higgs boson, and to a Nobel Prize for the confirmation of its existence. And this jump up in energy in 2015 represented the best chance that we as a species had ever had of discovering new particles, new answers to these long-standing questions, because it was almost twice as much energy as we used when we discovered the Higgs boson. Many of my colleagues had been working their entire careers for this moment, and frankly, to little curious me, this was the moment I'd been waiting for my entire life. So 2015 was go time. So June 2015, my colleagues and I, the LHC is switched back on. My colleagues and I held our breath and bit our fingernails, and then finally we saw the first proton collisions at this highest energy ever. Applause, champagne, celebration. This was a milestone for science, and we had no idea what we would find in this brand new data. And then a few weeks later we found a bump. It wasn't a very big bump, but it was big enough to make you raise your eyebrow. But on a scale of 1 to 10 for eyebrow raises, if 10 indicates that you've discovered a new particle, this eyebrow raise is about a 4. I spent hours, days, weeks in secret meetings arguing with my colleagues over this little bump, poking and prodding it with our most ruthless experimental sticks to see if it would withstand scrutiny. But even after months of working feverishly, sleeping in our offices and not going home, candy bars for dinner, coffee by the bucketful. Physicists are machines for turning coffee into diagrams. This little bump would not go away. So, after a few months, we presented our little bump to the world with a very clear message. This little bump is interesting, but it's not definitive. So, let's keep an eye on it as we take more data. And so we were trying to be extremely cool about it. And the world ran with it anyway. The news loved it. People said it reminded them of the little bump that was shown on the way toward the Higgs boson discovery. Better than that, my theorist colleagues, I love my theorist colleagues. My theorist colleagues wrote 500 papers about this little bump. The world of particle physics had been flipped on its head. But what was it about this particular bump that caused thousands of physicists to collectively lose their cool? This little bump was unique. This little bump indicated that we were seeing an unexpectedly large number of collisions whose debris consisted of only 2 photons, 2 particles of light, and that's rare. Particle collisions are not like automobile collisions. They have different rules. When 2 particles collide at almost the speed of light, the quantum world takes over. And in the quantum world, these 2 particles can briefly create a new particle that lives for a tiny fraction of a second before splitting into other particles that hit our detector. Imagine a car collision where the 2 cars vanish upon impact. A bicycle appears in their place. And then that bicycle explodes into 2 skateboards which hit our detector. Hopefully not literally. They're very expensive. The events where only 2 photons hit our detector are very rare. And because of the special quantum properties of photons, there's a very small number of possible new particles, these mythical bicycles, that can give birth to only 2 photons. But one of these options is huge. And it has to do with that long-standing question that bothered me as a tiny little kid about gravity. So, gravity may seem super strong to you, but it's actually crazily weak compared to the other forces of nature. I mean, I can briefly beat gravity when I jump, but I can't pick a proton out of my hand. The strength of gravity, compared to the other forces of nature, is 10 to the minus 39. That's a decimal with 39 zeros after it. Worse than that, all of the other known forces of nature are perfectly described by this thing we call the Standard Model, which is our current best description of nature at its smallest scales, and quite frankly, one of the most successful achievements of humankind.
Flick to link.
Except for gravity, which is absent.
A link to flick.
Standard Model. It's crazy.
My hypothesis is the Pinterest, because there